Hello, welcome to this channel. My name is Enoch. Today we will continue in our series on networking, and we will be looking at layer 3 of the OSI model. In my last video on networking, we treated the OSI model and we dealt extensively with the layer 1 and layer 2, and today we will be looking at layer 3, which is a network layer, and we will look at IP address, we will look at IPv4 address and IPv6 address, and we will look at Unicast and Unicast broadcast and multicast traffic. We will look at static versus automatic IP addressing. And let's get right to it. Layer 3 of the OSI model is called the network layer, and is responsible for moving packets from source to destination. It's responsible for logical addressing and routing. And it works for the transmission of data from one node to another, and which are located in different networks. And it works on the IP address. Data is assembled in packets in this layer, and the sender and receiver's IP address are placed in the header by the network layer. And so router is used in this layer. Switch are used to connect multiple network interface cards together, like saying a switch is used to connect multiple computers together, while a router is used to connect multiple networks together. So if I have an hall A with multiple computers connected together with a switch, and I have an hall B with multiple computers connected together with another switch, and I want computers from the hall A to an hall B to be able to communicate, I will need a router. So that's that. Router connect multiple networks together. You will know that switch connect multiple computers or network interface cards together. So the network layer provides connectivity and path selection between two hosts that may be located on a geographically separated networks. It manages the connectivity of hosts by providing logical addressing, and is responsible for routing packets to their destination and for quality of service. An IP address is the best known layer 3 protocol. We have some other protocol like the internet protocol, security, IPsec. We have the routing information protocol, RIP. We have the border gateway protocol, which is the BGP. We have the ICMP, which is the Internet Control Message Protocol, and IP address, is the best known protocol in this layer 3, and we are going to be looking at it extensively today. IP address is a connectionless protocol. It does not establish a dedicated connection between the sender and receiver before sending data. Instead, it simply sends data packets, called datagrams, independently, without ensuring that they arrive in order or even at all. So we have multiple types of IP address, which are IPv6 address and IPv4 address. So an IP address is a unique identifier for devices on a network, and IP, when data is sent over the network, the IP address tells computers where the data is coming from and where it is going. An IPv4 address consists of 32 bits and are typically written in dotted decimal format, as 4 numbers separated by period, like we can see in this place. You can see 192.168.1.1, and this is the binary representation of that. 192 is the first one, 168 is the second one, this is 1, and this is the last one. So IPv4 uses 32 bits, which is from this particular bit to this last bit. This bit is 8 bit. These are 8 bit, another 8 bit, another 8 bit, another 8 bit. If you add them together, that gives us 32 bit. So it uses 32 bit. So which means that there are 2 raised to power 32 possible addresses that can be getting from an IPv4 address, which equals to 4.3 billion addresses. So IPv4 address is a 4-octet dotted decimal format, and the first octet starts from the left, then you follow by the second octet, followed by the third octet, followed by the fourth octet. You can see this is the binary representation of this 192, and you can see it at 8 bits. This is a binary representation of this second octet. It's also at 8 bits. This is a binary representation of this 100, and it also has 8 bits. So 8 bit in 4 places, you have 32 bit. That's why we say it's a 32-bit address. And it ranges, each octet ranges from 0 to 255 in decimal representation. So if you look at it, 0.0.0, so each one there represent the binary format of each of these 0, and this 111 represent the binary format, the binary conversion of this 255. So you could have said that, oh, why don't we have 999 or 888? The reason we don't have that is because computers only deals with binary, with bits 111 and 000. So the highest we can have is 1 in 11111 in 8 places like that, which gives us a decimal conversion of 255. So that's that. So each octet can range from 0 to 255. That's what it means. The last octet can range from 0 to 255. Then the second octet comes in 0 to 255. Then the second octet coming 255. Then the first octet coming 0 to 255. So let's note that. And Internet Assigned Numbers Authority is the coordinating body for the IPv4 address. And because at the point they discovered that the IPv4 address is not going to be enough, that was what led to the creation of the IPv6 address. IPv6 address is a 128-bit IP address, which gives us an astronomical, number of IP address, that can be created from it. And many organizations today are just not changing yet to IPv6 address. Many of them are finding a workaround using private IP address with NAT, for their networks. They use private IP address internally, and they use NAT with the public IP address, for their network. So that's that. And we have unicast and broadcast and multicast traffic. And they are the 3 main IP traffic types, used in delivering data to specific or multiple hosts. And unicast is a one-to-one communication method where data is sent from one sender to a single specific receiver. Unicast traffic is to a single destination. And an example of a unicast traffic is your web browsing. When you're browsing, where each user requests and receive a unique response from the web server. SSH section is another example. So for unicast, you can have one computer with an IP address, that is sending multiple traffic to different IP address. So it's a one-to-one thing. And we also have broadcast traffic, which is a one-to-all communication method, and is sending data from one sender to all devices or hosts in a subnet or in a network. So, and an example of a broadcast traffic is like an address resolution protocol, where a device needs to find the MAC address of another device, on the network. I don't want this video to be too long, so I will not give much. I will not expand on that example. We also have the multicast traffic, which is a one-to-many communication method, where data is sent from one sender to multiple designated recipients who are part of a multicast group. Multicast is a situation where you send to a single address and multiple people who are interested, can connect to it. So an example is maybe your radio station or your video, your streaming live video, where multiple users can subscribe to the same multicast stream without duplicating the data for each user. So that's that about unicast, broadcast, and multicast traffic. And we have static versus automatic IP addressing. Situation arise in several networks where organization will need a consistent IP address, for their server or for their device, and all of the device, behind the scene can have dynamic IP address. This is what this is all about. So static and automatic IP address are two methods used in assigning IP addresses, to devices on a network, each with its own use case and benefit. In static IP addressing, an IP address is manually assigned, to a device on the network, and it remains the same until it manually changed, which makes it ideal for devices that need a consistent IP address, such as servers, printers, routers, switches, and network devices that should always be reachable at the same IP address. And we have several examples of that in several technologies that are out there today. If you look at AWS, if you look at Kubernetes, you have that. AWS has something like elastic IP address, which you can use for your infrastructure. You create an EC2 instance, you can request for an elastic IP address, which is a static IP, and the IP address of that particular EC2 instance will not change, even if you shut down that instance. Anytime you bring up that instance again, it will still retain the same IP address. Of course, you'll be paying for that IP address. And we also have automatic IP addressing, which is also known as a dynamic IP addressing, which assign IP addresses automatically using a protocol using DHCP, which is dynamic host configuration protocol, to devices like desktop, and laptops. So we have subnet mask. A subnet mask is used to create boundary, to set a boundary between the network address and the broadcast address. When you have an IP address, there will be a portion that is like the prefix, that is consistent, and there will be a host portion that can be assigned to all the devices, on that particular network. So to set the boundary between logical networks, which the IP address is combined with a subnet mask. A subnet mask is a 32-bit number used in IP networks, to divide an IP address into the network and host portion. I will talk more about network and host portion very soon. So the subnet mask determines which part of an IP address represents the network and which part identifies the host within that network. For example, if you look at this IP address, is 192.168.10.15/24. The /24 you're seeing here is the subnet mask. This is used to determine the network portion of this IP address, and the /24 is telling us that they were using 24 bit for the network, and the remaining 8 bit will be for the host. So 192.168.10.0 is for the network, and this portion where 15 is remaining for the host, which can be from 0 to 255. So subnet mask help in creating subnet, allowing better organization, because you can simply just divide your big IP class into smaller subnet, and give it to different departments that need them. And security, because you can subnet helps, it helps in securing your network, because you can simply isolate a particular subnet, and it helps in efficient IP addressing, because it will reduce wastage of IP address. And IP is combined with the subnet mask to set the boundaries, and subnet mask can be written in dotted decimal or slash notation, like you see /24 like this, and you can also write it like this in dotted decimal, which is 255.255. This is telling us that the first 16 bits are for the network. Once you see it like this, this is for the network and this is for the host. So something like that. So a router is used to link different subnets together and route traffic between them. So the way the host knows if the destination is on a subnet or not is by comparing the IP address of the destination to its own IP address and the subnet mask. So if the destination is on a different subnet, it will send it through the local router, which is the default gateway. The network and host portion of an IP address can be easily identified using the subnet mask. So the host IP address is divided into network portion and a host portion, and the subnet mask defines where the boundary is between the network part and the host part of the IP address. So if you look at this, just like the example I used earlier, so we can write the IP address out in binary notation so that we can understand it better. This is the binary notation of this. This is a binary representation of this IP address, and this is a binary representation of this subnet mask. And if you look at it, where this one is, that's where the network portion of this IP address ends, and this where the 0 start is the host portion. This is the host portion. So 8-bit is used for the host, 24-bit is used for the network. So a 1 in the subnet mask indicate that bit in the IP address is part of the network address. A 0 indicate the bit is part of the host address. Let's note that. If the host want to communicate with another host with an IP address which has the same network address, it will simply communicate with it directly using the switch. But if it wants to communicate with another host on another network, it will communicate via the router. So that's that, and it will be able to identify if it is in its network or not using the subnet mask, and the IP address. So valid subnet mask usually comes in block of ones, looking at this like this, you can see that this comes in block of 1. If you see them mixed together with 0, then it's not valid. The subnet mask always begins with 1. If you look at this 111 is a valid subnet, but if you look at this is not a valid subnet mask. It's always in a block of 1s and block of 0, always. So the host portion of the address is available to be allocated to different hosts on the subnet, which can range from 0 to 255, whether it's PC, server, or printer, or whatever. You can use the host portion to allocate IP address to those devices. So the host address, the host portion of the address specify the individual host and must be unique on that subnet. You cannot assign a single host address to multiple devices. It will cause problem, and the system will not know which one to send information to when that data is sent to that particular address. So it doesn't have to be sequential. You can have 10.10.10 on one particular machine, and you can have another 10.10.10.20. So you can have 10.10.10 to you can have two different hosts with the same IP address, like 10.10.10.10. You can have a single address, for two different hosts. It has to be unique. So that's that. And the network address, the first IP address in a subnet is used to identify the subnets. The network address is determined by the subnet mask. We know that. And if you look at this, for example, and we look at this particular binary representation, the network address in this particular subnet or network will be 192.168.10.0. That will be the network address for this particular subnet. So all 0 in the host portion designates the network address, and it is not allowed to be allocated to a host. So this portion, as it's 0 0 like this, it will give you 0, and it's not allowed to be allocated to any host. The 0 is not allowed because it's part of the network. It belongs to the network address. So in the example above, the network address is 192.168.10.0. So you cannot assign this to any particular host. It's reserved as the network address. So the last IP address in the subnet is used to broadcast to all the devices in the subnet. The last IP address in the subnet is used as the broadcast address. So for example, now in this particular example that we have above, which has /24 subnet mask, the last IP address in this is what? 192.168.10.255. That's it. The broadcast address is 192.168.10.255. So we can assign the broadcast address to any individual host. It's used to broadcast to all the devices in the subnet. So any traffic that is sent to this particular IP will go to all the devices on the subnet. So and the usable IP address in every network are the possible host IP address from outside of the network address and the broadcast address. So the IP address between the network address and the broadcast address are the usable IP addresses. So for example, in this example now, with a subnet mask of /24, the usable IP addresses are from 192.168.10.1 to 192.168.10.254. You cannot use 0.255 is the broadcast address, and you cannot use 0.0 is the network address. So that's that. And we have IPv4 address classes from class A, B, C, D, and E. And class A IP address ranges from 0.0.0.0 to 127.255.255.255 with a default subnet mask of /8. So class A IP address has a default subnet mask of /8. So you have a situation where you have a small network but a large host. The first /8 means that the first 8 bit is used for the network, which means that 2 raised to power 8 can give you 256 possible networks, and the remaining 24 bit is for the host portion. So 2 raised to power 24 gives you about 16.7 million possible hosts. So class A addresses are assigned to networks with a very large number, of hosts. So if you have an organization that needs, a large, IP address set, they can go for class A. And every class A to class C has private IP address ranges. So for class A, the class A private IP address ranges from 10.0.0.0 to 10.255.255.255. And the binary format of the class A IP address, is something like this, 127 something like this. And you can see that one thing that is common, one of the things that is common in both is 0. So the first bit of the first octet of every class A IP address starts with 0 when converted to binary format, and is used for identification of class A IP address. Every class A IP address will start with 0 when converted to binary format. So you have 126 possible networks in class A IP address, because the first IP address is reserved and the last one is reserved. 0.0.0.0/8 is reserved for default routing, and 127. So you cannot use 0.0.0.1 to 0.255.255.25. They are not valid host addresses. And 127.0.0.0/8 is also reserved for loopback and diagnostic. You cannot use this; they are reserved. So you cannot use this 127.0.0.1 to 127.255.255.255 cannot be used. So therefore the number of usable class A network will at 126, ranging from 1.0.0.0 to 126.0.0.0. And the range of the usable hosts are between 1.0.0.0 to 126.255.255.255. And usable host in a class A IP address is 2 raised to power 4 24 minus 2. This minus 2 is to remove the broadcast address and the network address. So every class A IP address, we have about 16.7 million hosts, that is available to them. So so Class A IP address are designed for very large networks with a large number of hosts and can be used in large organizations or internet service providers. So an enterprise would definitely not put all 16.7 million hosts in a single local network. It will be bad for performance and security. So they will split them into smaller subnets and allocate them to their different departments. And we also have Class B IP address, which ranges from 128.0.0.0 to 192.255.255.255. And Class B IP address has a default subnet mask of /16, meaning that the first 16 bit of this network will be Class B address will be used for the network address. So, and this allows for 16,384 networks and 65,534 hosts per network. And with a default subnet mask of /16, you have it as 255.255.0.0 if you convert it to binary, and they are assigned to medium size to large size network. And the first 2 bits of the first octet of every Class B IP address start with 10. If you convert this is a Class B, so start with 10. 191, which is the last network, 10. So that's why the first 2 bits of the first octet of every Class B IP address is reserved. It's used for identification purpose. So the first 2 bits are reserved just for the purpose of identification. And the number of networks that can be created from Class B IP address range is 2 raised to the power 14, which gives us 16,384 possible networks. So number of possible hosts per network will be 2 raised to the power 16, which means because we have 16 bit left for the host, and we remove 2, and you get 65,534 after you remove the broadcast address and the network address. So the Class B private IP address ranges from 172.16.0.0 to 172.31.255.255. So every private IP address are not internet routable. All other ones are internet routable, but the private IP address for both the Class A and this IP address range for the Class A is not internet routable. It's a private IP address range that should be used in your own local environment. And Class B private IP address, this range is not internet routable. It should be used in your own local environment. And we have Class C IP address, which ranges from 192.0.0.0 to 223.255.255.255. This should be 255. I made a mistake there. And it has a default subnet mask of /24. So, and it's used for small networks, because it has just 8 bits left for the host. So when you have a network that just needs maybe less than 254 networks hosts, 254 hosts, then you can use your Class C IP address for that. And it allows for Class C IP address range allows for 2,097,000 possible networks and 254 hosts per network. And it has a default subnet mask of /24. And the first 3 bits of the first octet of every Class C IP address start with 110 when you convert it to binary. And the first 3 bits are reserved just for the purpose of identification. See, if you convert this IP address to binary, you see 110, the last range there, 1102. So they are reserved for identification, and the number of networks that can be created from Class B is 2 raised to the power 21 after we have removed, the first 3 bits away. Once you remove the first 3 bits, you are only left with 21, and 2 raised to power 21 will give you 2,097,000. And number of possible hosts is 2 raised to power 8 minus 2, which gives us 254. So we have a class C private IP address which ranges from 192.168.0.0 to 192.168.255.255. And so the private IP address for each classes are not internet routable. They were originally designed for host in a closed private network with no internet connectivity. So if you have a school, or if you have a school or an hospital or a kind of network that you don't want to connect to the internet, you can use your private IP address for that. So we also have class D IP address range, which is used for multicast. Is multicast group, and it ranges from 224.0.0.0 to 239.255.255.255. And these addresses are not allocated to host, and there is no default subnet mask. They are reserved for the multicast group, and they are used to send data to a group of destination computers simultaneously. So the first 4 bits of the first octet of class D IP address always start with 1110. See 224, if you convert it, 1110, 239, 110, 1110. See, and that's why the first 4 octets will probably be reserved or something like that. If it were to be used in public, it's used for identification. We also have class E, IP address range, which is reserved for future and experimental use, which ranges from 240.0.0.0 to 255.255.255.255, and is reserved for its experimental purpose. It is not used in standard network. It has no subnet mask. I just made this summary here so that you can get it, that the first bit of a class A IP address is 0. The first 2 bits in a class B IP address of the first 2 bits of the first octet in the class B IP address are 1 and 0. The first 3 bits, of the first octet in a class C IP address are 110, and the first 4 bits of the first octet of the class D IP address are 1110, and the first 4 bits of the first octet in a class E IP address are 1111. So this pattern helps routers and other network devices quickly determine the class of an IP address and undo them accordingly. So this is the summary. Just look at it. Class A start from 1 to 126. Class B from 128 to 191. Class C from 192 to 223. Class D 224 to 239. Class E 240 to 255, and their default subnet mask. So that's that for today. Thank you for watching. I will see you in the next video.